All righty, so this is a video actually going to do the problems for you. I want you to try them on your own first on a piece of scrap paper, but then I'm hoping that you actually are going to watch this video. I'm going to find out, that's for sure. That's why I'm doing this, because I don't think some students are necessarily putting the effort into the course that they should be putting into it. So a little mirror into your work ethic here. So for 1 point on your next test, the first 4 problems on this sheet, the front side of this sheet, I expect to be done properly and in the manner that I'm going to do them for you right now. So let me go shut the door on the classroom so I don't get disturbed. I think I had a typo on problem 1, but I put a little pencil mark through the minus sign. So I'm not trying to give folks a completing the square problem. I want something that can be factored so we can get some good factoring practice. All right, so quadratics, I will make one quick comment here. Ax squared plus bx plus c equals 0. Generally, you want to set quadratics equal to 0. There are 3 types. There's the ax squared plus c type equaling 0. There's the ax squared plus bx equals 0. So those are the 3 types of quadratics. Why don't we call them A, B, and C? And A is, you can use inverse operations. You got addition, multiplication, and squaring. So you got inverse operations. So we wanted to solve that. We just bring the C over, we divide it by A, we get it with plus minus square root. And we find out if that is a real number or imaginary number, but we're done. Very simple. So that's type A. Type B, very simple. You can certainly take out what's common. It doesn't have to be the greatest common factor. I always just take an x out. I don't care if it's a 2x squared plus 6x. I write it as x times 2x plus 6. I can see a 0 and I can see a -3. I think I made a mistake here. Did I? No. A little tired, but you want to factor those. All right, and it's a piece of cake. So type B. Type C, well, that's another ballgame. We could put it in graphing form and do inverse operations. Sometimes that's quickest and easiest. We can factor it. Sometimes we can, sometimes we can't. And if you can't factor it, then you got the completing the square process, which is what putting it in graphing form is all about. Or you can go with that cumbersome quadratic formula, which we haven't practiced a lot. And maybe we should have done more of that. But we certainly are practicing memorizing it right now. And that should resonate with you. So type C quadratics take experience as to what's the quickest and easiest way to solve. All right, so here are the first 4 problems on your sheet for 1 point on the next test. I am going to set it to 0. N squared minus 7n minus 30 equals 0. Then I'm going to think about the factors of 30, which are 1 and 30, 2 and 15, 5 and 6, 3 and 10. I guess I'm on a sequence there. And looks like 3 and 10 is the winner here. So we've got ourselves n minus 10 because we want the negative to win out in the foiling process. N plus 3. And this is the first mistake people made on last night's homework. This is an equation. We're looking for answers. Yes, you factored it properly. Happy for you. But it's still an equation and it still deserves answers. All right? That and that is what I'm looking for. Okay, so hopefully if you're watching this video, you can copy that. I'm sure you follow it. A lot of you certainly got the factoring, but another couple of steps. Just take the pencil, make sure you do those steps, and you got a little muscle memory. All right, now we're going to verify whether or not it's true. Then what's the quickest, easiest verification here? Plug the answers in and find out. Let's put a 10 in. And I can already see that I've made a mistake. Oh, I made a mistake in copying. See? Verification. That's why we're doing this. Okay, and I told you, or if I didn't early on, I'll tell you now, I'm half asleep. Let's see if I can get myself to wake up a little bit more. All right, so 10 squared minus 7 times 10. Line up the equal sign. Let's find out if that's true. 100 minus 70 equals 30. I think I can put a check and say I verified, and I can actually read what I've written. Then let's also try -3. -3 in parentheses squared minus 7 times -3. Let's see if that equals 30. Let's line up our equal signs. 9 minus a minus is a plus, 21. I think I'm ready to move on. And I don't think that taxed anyone in terms of time. All right, so now we're going to do the next problem. And I did throw something other than a quadratic your way. I don't know why. I could have left it as a quadratic, but I think maybe I was planning on actually doing this for you before you take your test. And if that's the case, I didn't want to actually do a problem in front of you that was going to be on your test. So I think that was my rationale. Next problem, 5x cubed plus 11. This is problem number 3. 5x cubed plus 11 equals 20. Okay, this is fine for my class, lining up the equal signs, subtracting 11, dividing by 5. I actually prefer it if you do this, rather than writing out everything on the left side, because I value thinking more than just, what do I want to call it? Tedious mechanics. All right, so we got to do undo cubing, which is cube root. All right, so a little bit of organization on your homework sheet. I can follow that very quickly and easily. I can follow it quicker than if you write 5x cubed and x cubed. I can actually compute that a little more easily. So now we want to verify. Problem 4, we're going to verify if x equals the cube root of 9/5 is actually going to work. Let's move this down a little bit. Organizational purposes. So 5 times the cube root of 9/5 is going to get cubed. And we're going to add 11. We're going to find out if that indeed comes out to 20. So 5, looks like these are inverse operations. So that gets us 9/5 plus 11. Does that equal 20? I think we can see the cancellation of the 5s. We've got our equal signs lined up. We got a little organization in there. If you can simply copy those 4 problems, I'm going to give you a point on your next test, because at least it moves us in the direction of more people in the class doing their homework with a little bit of mindfulness. Now we're going to do the backside. Solve minus 2x squared equals 7x. Make sure that the camera is situated properly so that we can see the work. Oh yeah, plenty fine. So problem number 5, backside. Let's see if I can remember what I said. I can't. I think it's minus 2x squared. Oh, I did remember. Minus 2x squared equals 7x. Okay, I've been saying keep your coefficients positive when possible. It's just going to eliminate a careless error or two in your career. So let's set this to 0 on the left side. Let's bring the 2x squared to the right, and let's put it in descending order. That's how you express polynomials in descending order of power. And now that's a type B quadratic as discussed at the beginning of the video. So I'm simply going to put it in factored form, and it's an equation. I'm going to remember to keep it set to 0. And therefore, I think I can see the answers. Don't need to write that. So my answers are 0 and -7/2. Okay. And I meant to do this on the first problem, but I didn't. Minus 2x squared. This is minus x squared. It's that parabola. Minus 2x squared simply takes whatever y value that is and doubles it and makes it a narrower expression on the graph. So just thought I'd say that. So minus 2x squared is a cup-shaped down graph. And 7x is just a linear function that's going up very quickly through the origin. And I can already see one of the intersections is at 0, and the other is some x value over here. And I think it might be that one. Right? So it's good to picture these graphs. But for our verification purposes, we're just going to come over here and substitute our answers. The first one I'm going to substitute is 0. Minus 2 times 0 squared equals 7 times 0. I do believe 0 equals 0. So I think that answer works. And then we're going to try minus 2 times the other answer, minus 7 halves. And we're going to square that. We're going to see if that is identical to 7 times minus 7 halves. Well, this side is easy to do. That's minus 49 over 2. Which I guess is the altitude. That's the altitude of that intersection. Right? And this one is minus 2 times minus 7 squared is positive 49 divided by 2 squared is 4. Okay, that goes in minus 49 over 2, which happens to be minus 49 over 2. I don't think I made any careless errors. 5 and 6 in the bank. Should have said 6 there. Okay, next and final problem. Not a very long homework, just making you reconnect with something we struggled with a little bit. 2x minus 2, get the glasses on. I didn't type that very big. 2x minus 3 over 5. So problem 7. 2x minus 3 over 5 minus x plus 1 over 4. And we had a lot of trouble with that one on the last homework. So one more time. Bingo, bango, bongo, a problem like this. Do the parentheses. Normally, I actually don't do that out because sometimes you can cancel with some factoring down the road. But for this problem, let's just do it this way. Okay, so again, parentheses. I'm highlighting that step. All right, bingo, 2x minus 3 times 4. 4 times 2x, 8x. 4 times minus 3, minus 12. It's a subtraction problem. 5 times x, 5x. 5 times 1, 5. This is one of the most important skills you want to have come out of a first year of algebraic study. When you subtract something, this is a number. When I put a value in here, like 7, I get the number 40. I have to subtract that quantity. I have to subtract each part in that quantity. Putting the parentheses there highlights that fact. So 5 times 4, common denominator of 20. Final state, unless we have to reduce here at the end. 8x minus 5x, 3x, minus 12, minus 5, minus 17. Now, let's find out if I made any careless errors. So we go back to the original. Here's our verification over here. How am I going to verify for on a final exam that I didn't make a careless error? How do I verify that? Well, that's algebra is supposed to be, this is supposed to be true for every number. For any number I pick, this should be true. So what would be a nice number here? Nice number here would be 6 maybe. 3 times 6 is 18 minus 17 is 1 over 20. Do I like 6 up here? Let's find out. Let's let x equal 6 and let's see if it comes out to be 1/20. Because if it didn't, I guess I can't make this statement. All right, so how friendly is the number 6? 2 times 6 is 12, minus 3 is 9/5. I don't have a problem working with 9/5. 6 plus 1 is 7 over 4. What am I doing with these? I'm subtracting, so let's bingo, bango, bongo that. 36 minus 35 over 20, which happens to be 1 over 20. Didn't take long. I checked it. I just did 8 problems, checked them, no errors. Okay, you can copy that. I don't care. I just want to make sure what you do at night isn't wrong. Because last night, most of what you did as a class was wrong. So you got very good at doing something wrong. And that's not what we're after. All right. See you in class. And hopefully you hand in your assignment. If not, I'm going to know it. Where am I? Over here. Bye-bye.